Assalamu alaikum, guys. Welcome to this first class of O-level chemistry. Starting out right now. Okay, so I'm Shafat Khan, as you guys might know me. And guys, all the videos before this lecture have already been uploaded to my YouTube channel, youtube.com/Shafat Khan. I'll just put it down here so that you guys could access the recordings over there as well, the free recordings which are over there, and this demo class is also free. So, and the chapter that we are going to complete in this class is called atomic structure. All right, so welcome guys, and let's begin. If you guys have any question, you may ask in the comment section. Okay, so now there we go. All right, guys. So the chapter is atomic structure. All right, atomic structure. Before we move on to the chapter itself, we first need to understand a few terms. Okay, and what are those few terms? The first term is atom. What is an atom? All right, and this is the very basic definition that we need to learn. And in fact, guys, this definition has been asked in the past papers as well. And by the way, guys, the examiner does ask you, well, sometimes he does ask you to write it down. All right, so we've got one question, one response over here in the chat box. It says the smallest particle of an element. All right, smallest particle of an element, that's one part of the definition. Smallest unit of matter, yeah, that can be the other part of the definition. But guys, that's not gonna give you full credit, okay? Because there are other the complete definition that the marking scheme would want you is as follows. Okay, I'm gonna write it down over here. Atom, as you guys said, it is the smallest particle of an element, right? So atom is a fundamental means the basic building block. Okay, it is a fundamental particle of an element that takes part in a chemical reaction, that takes part in a chemical reaction and has the same chemical properties as the element itself. As the element. All right, guys. So now the key terms in this definition are pretty simple and straightforward. Let's just one sec. All right, so now let me just point out the key terms to you guys. Over here, it says a fundamental particle. That's one key term. Of an element, that's the other key term. Taking part in the chemical reaction is another key term, and has the same chemical properties as the element is another important point in this definition. Although the examiner won't go into this much detail, but I've given you a bit extra so that if you guys could remember even half of it, you could get full credit. But guys, this is a pretty simple and pretty basic definition of an atom. What is an atom? In simple terms, it is the smallest particle. Okay, the smallest comes over here. Of an element. Okay, what is an element? Element is any pure substance. Okay, a very pure substance that cannot be further broken down, okay, into simpler substances. Kya matlab broken down? Well, broken down means, for example, I'll just give you an example of oxygen gas. Oxygen gas, no matter whatever you do to it, you cannot break it down into simpler substances by just heating it up. Okay, yes, correct, Maria. It is, element is any substance that is made up of a single type of an atom. Okay, so what is an element? Element itself is any substance. It is a pure substance, in fact, pure substance that is made up of only one type of an atom. Okay, that's an element. If you guys have questions, please keep asking. Okay, you guys are allowed to ask as many questions as you want. There is no silly question. There is no stupid question. You are here to learn, and please ask any question you want. I'll repeat 10 times if you want me to repeat, okay? But I want all the stuff clear in your heads. Okay, So now this was the definition of an atom, and in the exams, if you are asked to write down the definition of an atom, this is what you are expected to write, okay? Although the examiner won't ask you the definition of an atom because this is very, very basic. But in your school exams, of course, they might ask you to define an atom. So what is an atom? It is the smallest particle or the fundamental particle of an element that can take part in a chemical reaction, and it has the same properties as the element. Okay, what do I mean by the same properties as the element and the same chemical properties as the element? Well, what does chemical means? Chemical properties mean if it undergoes any chemical reaction, it will have the same chemical reaction as the element itself. Okay, irreversible. What do you mean by irreversible? Can you elaborate that, Maria? Okay. All right. So basically, nothing. Okay. Um, Now, see, for example, if I have oxygen gas, okay, let's say I've got let's say 10 cm cube of oxygen, 10 cm cube of oxygen, okay, in a gas jar. And now this oxygen over here that I have, this oxygen is your element, right? Element. And the atom that is making up the oxygen gas is an oxygen atom. Okay, this is an oxygen atom. The chemical properties of these two is going to be the same. For example, if I react oxygen with something, for example, carbon, it's going to give me carbon dioxide gas. Okay, if oxygen combines with carbon, it will give me carbon dioxide gas. Similarly, if I combine this oxygen atom with a carbon, I can still get a carbon dioxide gas as well. If I take two atoms of oxygen, I can still get carbon dioxide, right? So this is a chemical reaction that is taking place over here. Isn't this a chemical reaction? It is a chemical reaction, right? What is a chemical reaction? Chemical reaction is any reaction in which two chemicals are reacting, okay? Chemicals, they react with one another, okay? They react with one another, they combine together, taking in some energy, giving off some other amount of energy, and converting into some other chemical substance. That's a chemical reaction, okay? Their properties, they change completely after undergoing this reaction, okay? So now these two, since this was an atom and this is an oxygen, this is the element itself, but since they underwent a similar chemical reaction, they gave us a similar product. See, so the chemical properties are similar. Any questions so far, guys? If you have questions, you may ask. Shazib, any question? Shazib, did you get this part? Or do you want me to repeat it? Should I repeat it? No? All right. Now, basically, this was about an atom. Okay, it's clear. All right. Now, so um, kindly do take this down in your notebooks. Okay, please take this down in your notebooks and then we'll proceed. All right, guys. So now I'm assuming you've completed it. So now let's proceed with further stuff. All right, so we are done with the definition of an atom. Now let's look at the structure of an atom. All right, so an atom is, since you guys are in O level and in O level chemistry, so you guys should know the very basic structure of an atom. All right, so basically what an atom looks like. An atom contains a nucleus. Okay, what is a nucleus? Nucleus is a centrally located mass. Okay, this is your nucleus. Okay, a centrally located mass, a spherical dense mass. Okay, and around the nucleus there are electron shells. Okay, these are the electron shells around the nucleus. Okay, so this is the basic structure of an atom that you guys are supposed to know. Okay, and made up of electrons, protons, and neutrons. Yes, correct, Maria. They are made up of protons, neutrons, and electrons. Now let me tell you what this actually looks like. Okay, so this is your structure of an atom. All right, now this atom over here, it contains, as you stated, it contains even smaller particles. Remember, you guys told me in the definition that atom itself is a very, very small particle of an element. Basically, the smallest particle of an element that cannot be broken down into further into further substances, right? That's what an atom really means. But over here, if we go into the structure, deep into the structure of an atom, we'll find out that there are other particles, even smaller particles present within the atom itself. These particles are called subatomic particles. Okay, what are they called? They are called subatomic particles. These are present inside the atoms. Subatomic particles. And what are these particles actually doing inside the atom? They are actually forming the atom. Okay, these subatomic particles are holding the atom together. Okay, they are the atom is actually made up of these particles. Subatomic particle means the particles which are present inside the atoms, and these are even smaller than the atom. So what is the first property? They are found inside the atom, and secondly, they are even smaller than the atom itself, smaller than the atom itself. Okay, these are called the subatomic particles, and there are three types of these particles actually. Protons and electrons are equal, neutrons are not equal, it may be different. Yes, correct, Shazib. Let me just come to that point. Okay, just give me a bit. Okay, I'll just come to that, but please understand this concept over here. This is a very, very high yield concept. Okay, the subatomic particles, they are present inside the atom. Okay, they are actually forming the atom itself. Okay, and they are smaller than the atom, and there are three types of subatomic particles present inside the atom itself. Okay, and what are the examples? As Maria stated, the examples include protons. Wait, just a bit. I think the thickness is too small over here. Protons, we have neutrons, and we've got, what's the third type? Electrons. These are the three types of subatomic particles found within the atom. Okay, and now we must know the position of each of these particles, because the position is a very, very important point. And the examiner might ask you to draw out the structure of an atom. Okay, so now you must know how to draw out the structure of an atom. This nucleus that we have in the center, this nucleus contains two of the three types of subatomic particles, namely the protons and the neutrons. Okay, inside the nucleus, we've got the protons and we've got the neutrons. These are the two subatomic particles found inside the nucleus. What is a nucleus? Nucleus, well, actually, nucleus means anything that is located in the center. So since this is a mass that is located in the center of the atom, that's why it's called the nucleus of an atom. Okay, just like the in living cells, actually, you have got the nuclei present within the center of the living animal cell. Remember, animal and plant cells in biology, you've got nucleus present in the center of the cell. Similarly, you've got a nucleus present in the center of an atom. Okay, nucleus is present in the center of an animal cell. Similarly, it's present here as well. And now, guys, the third type of subatomic particle, which is the electron. These electrons, they are found revolving around the nucleus in their orbits. Okay, meaning they are present in these electron shells. Okay, these are the electron shells around the nucleus in which the electrons are present. Okay, and now different shells can contain different number of electrons in them. Okay, now the very first shell over here, this is the very first shell. Okay, the number of shells is represented by this value n. Okay, okay, you don't need to know that detail over here in O levels. Okay, Just ignore this n for a while, okay, because it's in A levels, it's actually a part of A levels, so kindly ignore that, okay. This n, kindly ignore this this n. Yes, correct, Shaze. Protons and electrons are actually equal, but let me just come to that point, okay. Now, first of all, yeah, okay, all right. Now, basically, this is the first portion, and the central portion, this is centrally located. The nucleus is central, okay, in position, whereas these shells around the nucleus, these are present around the nucleus. These are called shells, or they may also be called orbits. Okay, you may call them shells or orbits, or you may also call them energy levels. Okay, these are the three different names given to the same thing. Okay, the portion or the part of the atom in which the electrons are present are called shells or orbits or energy levels, or there is a fourth name as well. They may also be called quantum, principal quantum shells, but you don't need to know the fourth name, okay. These three are enough for you guys. Even one of them is enough, the shells is enough, okay. You don't need the other two, but it's okay to have this knowledge, because it's actually the A levels in which you'll be doing these other two names, okay. You might know orbits and shells only in your O levels, okay. So what are these pathways called, these irregular circles called? These are called electron shells or orbits, okay. Yes, shells or electron shells or orbits. And by the way, guys, different shells can carry different number of electrons. Okay, the very first shell, which is the nearest to the nucleus, the very first shell, let me call it shell number one. This is the shell number one, this is gonna be a shell number two, this is gonna be shell number three. The very first shell cannot carry many electrons, okay. It can only carry a total of 2 electrons. What can it, how many electrons can it carry? It can only carry a total of 2 electrons. You can not have more than 2 electrons in the first shell. That's a rule, okay. It's because of its low energy, okay. The energy is very low, so it cannot carry more than 2 electrons. If you move on to the next shell can carry up to 8 electrons, okay. 2, 4, 6 and 8. And by the way, guys, this cross represents electron, okay. Each cross represents 1 electron, okay. And these electrons, they are not stationary, they are continuously moving, okay. In these orbits, the electrons, they are continuously revolving around the nucleus in their orbits, okay. Now let's talk about the charges and the number of electrons and protons present. Right, so let me just quickly draw out a table for you guys. All right, proton, neutron, and electron. All right, and this is your charge and relative charge basically, and relative mass. Yeah, these are what I'll call. All right, so let's just quickly go over this table. Okay, what does this R charge means? R charge means relative charge. What does it mean? It means relative charge. And what does the R mass means? R mass means relative mass. Okay, relative means as compared to, okay? This proton over here, the proton, we give it a mass of 1, okay. We just assume that it has a mass of 1, although its real mass is not 1, okay. The real mass of proton is very small. If you weigh it out, if you measure its weight, अगर इसका mass हम measure करें ना proton का, तो ये बहुत कम आएगा, इसका mass 1 नहीं होता, ठीक है. लेकिन this is just an assumption, okay. This is just an assumption. Proton has a mass of 1. Neutron is equal to proton in mass. Okay, what did I say? Neutrons have the same mass as the proton, so it will also have a mass of how much? 1. Electron, on the other hand, does not have the same mass as a neutron or a proton. Electron is very, very, very small as compared to a proton or a neutron. Its mass is 1 upon 1840. Now, imagine how small this number is gonna be. 1 upon 1840 means you write down the 1 inside and 1840 outside, and then you apply your math on it. You divide it, so you'll have to put a point there, and then a 0, and then another point, and then another 0, and then another 0, and then this way another 0 and a 0, and then you'll have a number. Okay, so it's a very small number. The electron is very, very light as compared to the neutrons and protons. Okay, protons and neutrons are heavier than electrons. Clear? Did you guys get these three numbers? Did you guys understand this? If you have questions, please ask. Please ask in the chat box. Shazib, did you understand why I got this one and this one and this one over 1840? All right. Even in your book, if you'll find a table like this one. Okay. It's in some books it's written as 1 over 1840, or in other books it's written as 1 over 1836, but it doesn't matter. You can write any of these two. Both are acceptable. Okay. Now let's talk about the relative charge. Relative charge means the charge compared to the proton. Okay, in comparison to the proton. प्रोटॉन को देखते हुए इस न्यूट्रॉन का कितना चार्ज है एंड प्रोटॉन को देखते हुए इलेक्ट्रॉन का कितना चार्ज है, जिस तरह से यहाँ मासेस का किया था. ओके, रिलेटिव मास प्रोटॉन का क्या था? 1 था, राइट? सो द सेम थिंग. सो रिलेटिव मास, वी जस्ट assumed a mass, right? We just imagined that proton will have a mass of 1. So as compared to that mass, this is gonna be 1 because they are equal in masses, and as compared to that mass, this is going to be 1 over 1840 because electron is very, very lighter than the proton itself. Proton is very heavy as compared to the electron. Okay. Similarly, in relative charges, we are going to assume, by the way, protons are positively charged, neutrons are neutral. So we assume that they have a 0 charge. Okay, 0 charge represents neutrality, and electrons on the other hand are negatively charged. Okay, these charges are what you'll need to remember. You'll need to learn them because these are definitely tested on your exams. Okay, and by the way guys, the relative charge of a proton is also assumed to be 1. Okay, this is just a relative charge of a proton that is assumed to be +1. So neutron, since it's 0, so we don't need to do anything about the neutron. It is 0, it will remain 0. But electron, on the other hand, has equal and opposite charge as compared to proton. Okay, I'm using the term equal and opposite charge. Okay, so electrons are equally charged. Equally charged means if the charge of a proton is 1, then what's going to be the charge of an electron? Come on, I need an answer in the chat box. Yes, Shazib, what's going to be the answer? If I've written over here that they are equal and opposite, the charge of a proton is equal and opposite to the charge of an electron. No, it's not going to be 0. Electron has an opposite and an equal charge to the proton. It is equal and opposite. So equal means how much? If I assume that the charge of a proton is +1, then the charge of an electron is going to be also is going to be 1, right? But it's going to be opposite. It's going to be -1. Okay, it's going to be opposite. That's what the -1 means. Okay, opposite means बिल्कुल उल्टा. अगर वो +1 है तो ये -1 बन जाएगा. 1 is clear because they are equal. Clear? Now this table that I've drawn over here, this is very, very important, and you guys are supposed to learn this. I've explained this table to you guys. If you don't understand it, you can ask again and again. You can even refer to this video again and again. You can just replay it. Okay, it's gonna be easy. And this pretty much sums up the subatomic particles. Okay, so just a quick recap of these subatomic particles. We only have 10 minutes, I guess. Doesn't matter. I'm just gonna give you a quick recap of what we've done so far. Okay, in the beginning, I gave you the definition of an atom. What is an atom? Atom is the smallest particle of an element that takes part in the chemical reaction and has the same properties as the element. Okay, same chemical properties. So what are the three bullet points of an atom? Atom is the smallest part of an element, the smallest particle of an element, and it is, if it is the smallest particle, what else does it have? That takes part in the chemical reaction. It does takes part in a chemical reaction, right? Takes part in a chemical reaction. And what about the chemical properties? Are they the same as the element, or are they different from the element in which they are present? They have the same chemical properties as the element itself. Okay, same chemical properties as the element. All right. Then we talked about the structure of an atom. So within the atom, you've got a nucleus, and around the nucleus, you've got shells. Okay, this is your nucleus in the center, and around the nucleus, you've got electron shells. So an atom is composed of how many parts? Atom is composed of two parts in short. It is composed of a nucleus, and it is composed of electron shells. What is present in the shells? Come on, guys, I need an answer. Is the proton present in the shells, or an electron, or the neutron? On shells, there are electrons. Yep, correct, Shazib. In the shells, you've got the electrons. And what about the nucleus? Nucleus contains protons and neutrons. Correct? Yes, correct, Maria. Yes, Shazib, both of them, protons and neutrons, both are present in the nucleus. Okay, these are the electrons present in the shells. And by the way, guys, another very, very important point that I didn't tell you is that atom has no charge. Okay, no overall charge, no overall charge is present. It is not positive, nor is it negative. Okay, so if it has no charge, then we say an atom is electrically neutral. Electrically neutral. Okay, this is the term which means that atom has no charge, and electrically neutral because the positive charges are equal to the negative charges. Okay, the protons, which are the positively charged atoms, and the electrons, sorry, not the atoms, the positively charged particles, and the electrons, which are the negatively charged particles, they are equal, okay, within the atom. So since they are equal, the atom itself is electrically neutral, and neutrons have no charge. They are zero, they are neutral. Okay, and by the way, what's their relative masses? So electrons have 1 over 1840 as the relative mass, protons have a relative mass of 1, and neutrons also have a relative mass of 1. This is the summary of today's discussion. I hope you guys got it. If you guys have any questions, you may ask, otherwise we'll end. If you guys want to copy down something, you may. And thank you very much. This was our very first demo class. That's why it was a bit shorter, but next time we'll have approximately 1 hour long class. Okay, and thank you guys, you were wonderful. Okay, are there any questions? Okay, no problem, Shazib, you're welcome. Any other questions, guys? No questions. All right, thank you, and Allah Hafiz.